Hi, welcome to the mathcenter.com. In this video, we want to talk about the interpretation of confidence intervals. Now this is going to be a short video. We will focus on the interpretation of confidence intervals, and this is a section which appears in the topic, or if you like, the chapter on estimation, which you will find in a statistics course. May it be a pure statistics course or a business statistics course. So when you do estimation, you will have to do things like point estimation, and then you'll have to do confidence interval estimation. And as you go through confidence interval estimation, part of that question will involve interpreting the confidence interval. So we will be setting up confidence intervals for, let's say, for the mean of the population, mu. We will set up confidence intervals for the proportion pi of the population, and so on. So the point is, we will be setting up confidence intervals for parameters. Parameters means parameters describe a population. So for mu1 minus mu2, for pi1 minus pi2, and so on. Okay, so we're not going into how to set up the confidence intervals. We're just going to talk about how do you interpret the confidence intervals. Good. So here I've made a few remarks. First, let's say that we are talking about the 95% confidence interval for mu, the population mean. Okay? So, let's say we have done all the calculations and we have arrived at the confidence interval. So, again, we're talking about the 95% confidence interval for mu, the population mean. Okay, let's say we've done the calculations and we've arrived at the answers, and this is your confidence interval, the 95% confidence interval. So 7 here is the lower confidence limit, and 9 here is the upper confidence limit. Okay, so I've drawn a picture here. This is your 95% confidence interval. Now, where did I get these numbers? I just picked the numbers from thin air. We're just going to talk about an idea. Okay, good. Now, again, remember we're talking about how do you interpret this confidence interval. So let's read the correct statement. Okay, let's read the correct statement. The probability, the probability that this interval contains mu is 0.95. That's how you interpret your 95% confidence interval for mu that we have here. Again, the correct interpretation, the probability that this interval, this interval contains mu is 0.95. Another way you can say that you are 95% confident that this interval contains mu. Okay? The important thing that I'm trying to emphasize here is the probability must be connected to your interval. Okay, the interval has a probability. Okay, now you'll see the difference. Now let's read the wrong interpretation. The probability that mu, if you write this, the probability that mu lies in this interval is 0.95. It is wrong. You cannot write this. You cannot write the probability that mu lies in this interval equals to 0.95. It's wrong. Why is it wrong? Because you're giving mu a probability. Okay, mu is a constant. It describes a population. It does not have a probability. What has a probability is the interval. Because the interval, you'll have created this interval using sampling distribution. For example, let me write it down here. X bar plus or minus z, let's say alpha over 2 sigma over square root of n. So you would have used the formula for setting up a confidence interval for mu, and this interval here has a probability because we have a random variable here, x bar. Okay, so again, the correct interpretation, the probability that this interval contains mu is 0.95, or you can say you are 95% confident that the interval contains mu. Again, the wrong statement, you cannot write the probability that mu lies in this interval is 0.95. That's wrong. Okay? Now, take note, if you set up 100 such intervals, again, if you set up 100 such intervals, that means you have carried out sampling 100 times. If you set up 100 such intervals, you would expect, I repeat, you would expect 95 of them to contain mu. Okay, again, if you set up 100 such intervals, that means you carry out sampling 100 times, you will have 100 confidence intervals, 95% confidence intervals, and we can say that we expect 95% of them, we expect 95 of the 100 to contain mu. Again, yeah? If you set up 100 such confidence intervals, you will expect 95 of them to contain mu. Okay, so I wanted to tell you about the interpretation of confidence intervals because many times when you talk to students, they like to talk about the wrong statement. Okay, they like to tell you that the probability that mu lies in the interval is 0.95. So I'm going to tell you that this is wrong. So please make sure that you emphasize this. The interval has a probability. Yeah. So the probability that this interval contains mu is 0.95.